This is a plasma-filled dining room table. Powered by a rechargeable lithium battery that hides in the legs, it's filled with bright plasma that with the simple turn of a knob can extend down the length of the table and is attracted to your hands. It's completely mesmerizing. So I was in the market for a new dining room table, and after watching Tron one too many times... No, Clue is not your dad. I was inspired to build my own, something futuristic and elegant, and being me, that meant plasma. Because plasma is incredibly beautiful, it's inspiring, it commands respect, and is constantly changing the world of science. It literally flows through my veins. It was a challenge which included a great deal of 3D printing, woodworking, resin casting, and utilized custom neon tubes and custom power sources, involving multiple failures and a steep learning curve. I documented this lengthy journey, which led to just what might be the world's first plasma-infused river table. This video is proudly sponsored by Onshape, which I used during the building of this table. When I first started shopping around for new tables, nothing really fit the bill. Nothing felt like me. Some were flimsy enough to be blown over by a sneeze, others were designed for Goliaths, others more clearly designed for hobbits. This one looked like it belonged in a therapist's break room, and the cool tables were more than I wanted to spend. Overall, I wasn't impressed, until I ran across this table, which sparked an idea in my head. Scouring the interwebs for cool table ideas, I rediscovered live edge tables. You know, the type with a large piece of wood on top that's left with the natural edges? It's called a live edge. They're some of the most beautiful tables because they show off the beauty of the wood grain and the shape of the tree. There's an incredible variation called a river table where you place two live edges side by side and fill in the gap with epoxy. These are super cool, and after spending hours looking at examples online, I thought, what a perfect opportunity to put plasma on display. It would be incredible to eat at a table that's filled with interactive neon. I believe that creation just requires a dream and two hands, really, so I got to work thinking I'd be done in 2 weeks. Surrounding Seattle, there's a few suppliers for live edge cuts. A friend of mine recommended a place called Stormo's Hardwoods, which was about an hour from my location in Kirkland. So I headed out to Kevin's property, curious about what his selection of live edge would look like. It was a carpenter's paradise, with hundreds of cuts to choose from, and don't get me started on his personal workshop, which I wanted to live in. So I found a few prime pieces of English walnut and had him cut the pieces to 60 inches. And after carrying the stupidly heavy walnut into my living room, I realized this was not going to be a fast project. So I needed literal gallons of epoxy resin, custom table legs, custom neon tubing, high voltage power source, which I got that one on lockdown, but the other stuff was going to take a lot of time to get together. So I decided to start with the coolest part, which was the neon tubes. It took a bit of bean water, but I settled on a design that I was happy with. The neon tubing would follow the grain of the table and be composed of two separate curves. There were a few neon sign manufacturers around Seattle, and a place called Noble Neon gave me the fastest service. So they worked with me to make the curves that I needed for this table, and they also quoted me the fastest out of everybody, which was 6 days, which gave me plenty of time to figure out exactly how to do this. Because how to implant the neon required some thought. The glass tubing needed to be submerged deep enough to protect it from tabletop impacts and eliminate all risk of electric shock, but shallow enough to allow capacitive coupling to the hands and dishes. I'll dig into the capacitive coupling later, but finding what depth to plant the neon at was gonna take a bit of experimentation. So I built a short length of test tubing which allowed me to test the effects of various resin depths. One side covered with 1/8 of an inch of resin, another side is 1/4 inch, and lastly 3/8 of an inch. First up was 1/8 of an inch. Here goes nothing. Oh, yes! That is capacitive coupling at work. That's incredible. Next, I tried a 1/4 inch. Wow, it still works with a 1/4 inch, but it's kind of lagging behind a little bit. Not quite as good as 1/8 of an inch. This left the final depth 3/8 of an inch. It still works. But I definitely see a pattern. Okay, so it's lagging behind even more. Having a better idea of what depth to put the tubing at, I went ahead and cleaned up the rough edges of the wood in preparation for the resin pour. Check this out. That sander I'm using is ungodly loud, so I went downstairs to talk to my neighbor and just make sure I'm not like annoying the hell out of her. She can't hear a thing. I'm gonna have fun at this new place. Both myself and my apartment were covered in sawdust. As it turns out, it's generally frowned upon to simultaneously electrocute your dinner table guests while cutting up their arms. Who made this rule? So I needed the right resin to protect these neon tubes, which I didn't know at first. Hopping into the Amazon, I bought 4 gallons of epoxy resin, and this is the cheap stuff, and it was still shockingly expensive. It'll insulate the high voltage and structurally hold the entire table together. For this table, I really felt like it would be an injustice to just use clear resin and stop there. So to spice it up a bit, I plan to mix in some green or blue metallic pigment, but I wasn't really sure which one to choose, so I ran it by my girlfriend. Siri, what color matches best with orange?
Blue, you idiot.
The resin would be poured in 4 distinct phases, the first of which involved mixing a small batch of resin and applying a seal coat to all the edges of the wood. This was important because it prevents air bubbles from appearing in the final pour. Alright, it's the next morning and I stayed up way too late building this form for the table. It brings us to phase 2 of the resin pour, which will involve placing the slabs of wood in the form and then pouring the first couple quarter inches of the resin. Taking a moment to level the form in both directions, I then laid each piece of wood into place while somehow not smashing my fingers. I pulled out my vacuum pump and a new vacuum chamber I bought for this table and mixed together 2 full gallons of resin, adding a heavy dose of coloring. I mixed and I mixed and I mixed until both my arms fell off, then threw the batch into the vacuum chamber. I didn't know this at the time, but doing so was totally unnecessary and even detrimental. I poured the resin, which mysteriously started smoking, and patted myself on the back for a successful pour. Oh god. So I just came back from a run, and it turns out the entire resin pour was a failure. It sucked. There were cracks all over the resin, most of them all the way down to the form, and some of the resin had even delaminated from the edges of the wood. After lots of reading, I learned that tabletop resin's meant to be poured in 1/8 inch increments, not an inch like I did. That was a $130 lesson. I needed to remove the resin, so I cut it down the middle and took a hammer to the edges. I got really lucky, and it came off easily this way because it was already partly delaminated. Not only did the pour fail, but parts of the pour form were welded to the table as well. It was a total disaster, but I was determined to get this right, which meant planing the wood back down to fresh surfaces. So I drove out to a local lumber yard, explained how I was a total noob, and they kindly milled down my wood. This took a few hours, but it was strangely therapeutic. Without their help, I would have needed to spend several hundred more on wood and custom neon tubing.
These guys saved my project. These guys.
Instilled with hope, I built a second form, laid the pieces into their final resting place, and pulled out a ridiculous amount of resin. It was 4.5 gallons worth. Except this time, I bought the right type. Would you look at that? I can learn. I then threw together 1.5 gallons of it, mixed in the same blue metallic pigment, and churned butter for what felt like an hour. When I went to pour it, it ran like glistening metallic blue water. It was super pleasing to watch. It also wasn't smoking this time, which kinda seemed like a good thing. Finishing it off with a torch to get rid of all the surface bubbles, I had successfully won my first battle. It took a few days to cure, and after the first layer was hardened, it was time for the addition of a few special guests. I've kept every transistor, IC, and chip that I've killed over the years so that one day they could receive a proper burial, and I thought this table would be totally suiting, forced to stare into the divine light of plasma for all eternity as a recompense for their failures. I needed the neon tubing 1/4 inch below the surface, so I placed plasma cubes along the length of the tubing to act as supports. I then threw together a small batch of resin and mixed in a really small amount of pigment. The idea here was to make this layer of resin partially see-through. In the middle of mixing, I got a call from Noble Neon, so I rushed over to their little plasma paradise to claim my prize. Their workshop was incredible. Let me know if you'd like to see a video about how they make these neon signs. With glee, I drove the tubes home safely and placed them into their final resting spots. Connecting the tubes to their external connections on the edge, it was time for that next resin pour. I had no issues, and it went super smoothly. At this point, my vision was definitely starting to come to life. Once I torched the surface to eliminate all the surface bubbles, the resin was left to cure for another 48 hours. Alright, mid-pour update. It's been about 12 hours since I poured the last layer of resin and it's starting to harden up a little bit. So I'm going to mix together a third and final batch of crystal clear resin and I'm going to pour about 1/4 of an inch or 1/8 of an inch on top of the neon tubes. I let that cure for a day, day and a half, and then came the manual labor. Then came a mess so biblical, it'll be talked about for generations.
After a few days of curing, the table needed to be planed flat, and I was the schmuck to do it. So I planed and planed and planed until my hands legitimately fell off. I did this for 2 hours, but hardly made a dent in the work.
Ooh, this is a mess I'm proud of.
So I decided electricity was cool and bought some backup. It was also time to remove the edges of the pour form, which ended up being really therapeutic. This moment in particular. Yeah. I then turned on the hand gremlin and made short work of the rest of the table. This was therapeutic in its own way, I guess. This is where the real mess started, and I decided to just go with it. After just a few minutes, I felt like I belonged in the middle of Breaking Bad, and I became quite fond of my mess.
Finally done planing. And look at my beautiful mess. Oh, that's actually not the mess. This is the mess. All right there. I have never had to sweep the underside of a table. This is the most annoying stuff to clean up. It's staticky, and it sticks to everything.
Okay, so maybe I was less fond of the cleanup.
You have no idea how excited I was to be done with that. I damn near have PTSD from sweeping for like 4 or 5 hours. But at least the hard part of the project was done. And up next was something easy, the table legs.
With a bit of searching, I found legs that really resonated with my design and included a large negative space, which I was really excited about. As I went to mount the legs, I had no idea the bottom was so beautiful. I mean, look at the texture and the colors. Mounting was really straightforward. I just drilled and screwed. And with both mounted, I officially had a table. And a broken floor. This table weighs at least 200 pounds.
The open spaces are important because I'm making this a battery-powered table, so no cables. And after a bit of searching, I found a high-capacity battery that slides right into the diagonal of the frame. How sick is that? It's honestly a perfect fit, but with the high current wires coming out of the back and the fragile charging wires coming out of the front, I want to find a way to disguise this and cover up the battery. I mentioned earlier that all it takes is a dream in 2 hands, which is pretty much the case for any project, let's be honest. So, this was my solution to that. I decided to put my new 3D printer to use and build removable battery covers. And to design the battery covers, I needed a 3D modeling program. One problem though, I didn't know how to use CAD. And that's where Onshape saved the day. Let's take a look.
It's a really intuitive 3D modeling program designed by the same folks who made SolidWorks. It can be used to sync circuit design, create model sketches and simulations, and its 3D rendering game is on a whole new level. From manufacturing to engineering, it's pretty much geared towards everybody. And since Onshape is cloud-based, that means no downloads and the ability to work on your designs from any computer, anywhere. It's been a goal of mine for a while to learn 3D printing, which meant I needed to learn 3D modeling. The user interface of this program made the learning process really easy, and I was able to sketch up my first parts for this table within minutes.
And here's a cool perk. If you're doing a collaborative design process, sharing couldn't be easier.
Just click share and type in an email. So hard.
I definitely recommend giving Onshape a peek, whether you're a maker like myself or a business, and you can try it for free at onshape.pro/plasmachannel.
The battery covers took 2 or 2.5 hours to print and ended up snapping perfectly into place, which was super satisfying. I later reprinted these in gold color. Taking care to slowly mix some tabletop epoxy, I poured what's called a flood coat. I didn't quite mix enough, but I managed to spread it around. The torch once again removed air bubbles, and it was left to cure for 8 hours. After sanding, I poured a final flood coat and relished in the fact that the hardest part of this was done. Or so I thought. For now, though, everything had come together, and to go from simple glass tubes to a neon plasma paradise, the table needed the addition of one final item.
This table contained over 9 feet of neon tubing, which was going to require a fair amount of power to light up. And I don't like cables. What? Third side, of course. This is why I settled on battery power, and luckily I already had several high voltage power sources on hand designed to run at 12 volts. First option, power source from the ionic thruster, about 8 kilovolts around 15 milliamps, plenty of power there. Second option is the power source from my Kirlian photography build. Now this guy pumps out around 20 kilovolts at a couple of milliamps, so a different type of high voltage. And then in the middle I have a power source that's from a small plasma globe. This guy's a little bit finicky, but it does put out around 10 kilovolts at like 1 or 2 milliamps. So I have some options to screw around with here. Let's give this guy a try. Really? That's it? Well, that didn't work. This one carries a lot more power behind it, so we should be good. What? No. Oh, interesting.
I think the neon tubes presented too heavy of a load on the transformer, preventing the circuit from oscillating as it's designed to when directly attached, aka no high voltage. So on to my last option, which provided plenty of current.
Oh. Hell yes. You can actually see little waves of plasma going up and down the tube.
For more control, I added a PWM, which allowed me to dim the power coming from the battery.
Oh, that's incredible. Okay. Oh, and there's like the plasma waves again going up and down the tubes. It doesn't respond to my hands though. But I wanted more control over the plasma. My plan was to have it controllable up and down the length of the table and be responsive to your hands. So after some thinking, I came up with what I thought was a brilliant solution. A capacitively coupled high voltage switch.
It only took a few minutes to design with Onshape, and the printing took about an hour. I felt really smug about this solution. The high voltage wire slides into the base, and the connection to the neon tubes goes right into this little slider. In theory, as the slider moves closer to the power wire, it should capacitively couple more power into the tubes. More power, less. It's brilliant.
Update, maybe it's brilliant in theory, but not practice. Damn, that's close. It's kind of a cool effect. Works for 3 inches of tubing. Even though this lights up the tubes, I need more control over the plasma and also a power source that doesn't put out a high-pitched shriek. That'd be nice.
Recalling my ignition coil driver video, a 555 circuit is a brilliant way to drive both ignition coils and flybacks. All I needed was to build one designed to run at high frequencies, the frequencies of a flyback transformer. So that's exactly what I did. I made a custom flyback driver. After initial tests, things looked really promising. It was producing a square wave and frequency was adjustable from about 20 to 51 kilohertz. So I tried it on a random flyback.
Ooh, can't hear a thing. That's good news. That means that this guy's above the audible range and my problem's solved.
But this was a huge flyback and fragile, so I settled on a more compact AC flyback that I pulled from an air purifier. After a bit of thinking, I designed an enclosure for the flyback which securely held it in place under the table, and I thanked my 3D printer for existing. It turned out beautifully, 2 mounting holes and the flyback clicks right into place. I also printed a base to hold the 555 circuit in place and various other parts that'll hide under the table. Is this what it feels like to be in love, Integza?
Before mounting anything into place though, I had to make sure that this flyback actually worked as intended, and equally as important, what topography of connection to use for the neon tubes.
Wired in series, the circuit was working. I could control the plasma up and down the table. This was super exciting.
Yes! And here's what happened when I switched to parallel wiring. Capacitive coupling was in full swing.
Naturally, I was quick to tell everybody I knew.
I experimented with other connection styles as well, each one of them providing their own really cool visual effect. But the plasma was always glitchy. It would jump around and it really didn't like being controlled.
I racked my brain for days trying to figure out what was causing this because I wanted better control of the plasma. Eventually, I reached out to an old friend, the Boom Master himself. We exchanged ideas and talked circuit theory for the better part of 2 days. Mehdi's input led me to rebuild the entire circuit, and I'm glad I did. So I formally wired up the neon tubes to the high voltage supply, then crawled under the table like a table gremlin and mounted all 500 3D printed parts. I'd spent 2 months designing and building this table, investing an unbelievable amount of effort into it.
Everything about it was custom. Would it live up to the dream, the idea that I had in my head? Well, I took a deep breath and turned on the power. Let's do this. Oh! Yes! That is incredible. Wow. That is perfect. Absolutely perfect.
The table had really come alive and was even more responsive to touch.
Check this out. It's super sensitive now, and you can pretty much just draw with the plasma. Wee wee. Oh, this is exactly what I've been going for.
Finally, I'd domesticated plasma, and I've got to say, it was worth the effort.
This is a project that's meant to be shared and seen, and my friends hadn't really seen me in 2 months, so I figured I'd invite them over to take a look at my brand new high voltage Tron table.
This is so cool.
Thank you.
Oh my god.
Oh shit.
It took all of a second for them to wonder just how exactly is there plasma inside this table. My next friend really enjoyed the interactive aspect. He quickly realized he could control the plasma with his hands, and we had a lot of fun. Another set of friends stopped by, and my buddy Daniel really liked the dimmability of the neon. Overall, I think the table was a big hit.
The table might be cool, but the science is cooler. The interactive aspect of this table is all due in part to a form of wireless power transfer called capacitive coupling. Hear me out, it's actually quite simple.
Electricity comes in 2 main forms, alternating current and direct current. Both types emit an electromagnetic field around a wire, but AC creates a magnetic field that's constantly growing and shrinking. Well, at really high frequencies, the AC electric field easily affects nearby conductive objects by inducing an electric current in them. This table runs at tens of thousands of hertz.
Since we're talking about a field, these conductive objects don't need to be physically attached, and yet they'll act to wirelessly leach energy out of the system.
And if you're standing on the ground, even with socks on, you act as a pathway to ground, so the energy wants to exit the neon tubes wherever your hands are. Bring your hands closer and the plasma grows in an attempt to find ground. Place your hands halfway down the tube though and the plasma will shrink because you're stealing energy out of the system.
Capacitive coupling, that's the really general explanation. There's also other factors at play with this table, such as frequency shifting from power load.
Ultimately, this table was a practice in perseverance and problem solving, and a lot of learning occurred throughout the journey.
I love how it turned out, and let me know your thoughts in the comments down below, as well as if you'd like me to make a video on that adjustable high voltage power supply I built. A massive thank you to Mehdi for his help, to Onshape for existing, and to all of my Patreons who patiently support my work. But most importantly, thank you for watching. You stay classy.